Okay, welcome back to the Sem1 review. This time we'll look at 54 through 56. And in the first problem here, we're supposed to find the y-intercept. Now, something you should always remember about the y-intercept, let me just draw a little sketch here, is when you're, let's just give an example here. If your y-intercept were at that point there, then you would be at 0, 3. If in contrast to that, you were down here, that would be 0, -2. But what you know for sure is that the x value is 0. So that's how you solve these, is you simply put a 0 in place of the x. That's how you find y-intercepts. So y equals 1/3 times 0 minus 6 squared plus 8. So all we have to do is solve this here, or simplify it. And you do the parentheses first. So the next priority would be the squaring, and -6 times -6 is 36. And 1/3 times 36 would take priority over the addition, so that would be 12 plus 8. We have a y-intercept of 20. So basically, plug in 0 and see what you get. Okay, on this one, they give us a format of ax squared plus c and 2 points, and we're supposed to find the value of a. We're going to find the value of both a and c as we do this, but it's the a that they care about. So we're going to start with this x and this y, and if you plug those in, you get -3 equals a times -1 squared plus c, which then leads to 1a plus 1c equals -3. And all I did is I squared the -1. Okay, we'll use a new set of x and y values. Which, when you rearrange it, gives 4a plus 1c equals -9. All right, so now we're going to switch gears and use our calculator and the matrix features on it. And you'll be typing x equals a inverse b here. So in practice, you're going to set up a 2x2 matrix with these numbers in it. You'll touch the inverse key, which is on the left-hand side. I think it's about the 4th key down. It looks like this, by the way. That's the key you'll hit. And then you put in the constant matrix of -3, -9. And when you do this, and you'll have to give me a second here because I have to do it on my own calculator. Okay, I'm working on it here. If you'll be patient. You end up with -2, -1. Now, because the first column is a, this would be the a value. And then c value is second, so this is the c value. And the problem just wants to know what a is. So a equals -2 is your final answer here. Now, if it asked for the equation, you'd take it a step farther. You'd say y equals -2 for the a, x squared plus the c value of -1, and that would have been your answer if you were asked for the equation. Okay, number 56, I forgot to write down, but here's what we're going to do. We're going to find the maximum height of y equals -2x squared plus 16x plus 5. That's my model. Your problem's slightly different, but that's okay. And we want to know what the max height is. So you're going to start by finding h, and you have a little formula for that. Now, kind of the overview here is that if you find the vertex is at the highest point. Now, that would be true when the parabola is upside down here. And with a negative up front, that's the case. Now, when you flip this over and you have a positive up front here, then you would get the vertex at the lowest point, and you'd have a minimum value. Okay, the opposite of 16 is negative 16, and here you have 2 times the a value. So negative 16 over negative 4 is 4. And so now you know the first part of your vertex. Now we'll find the k value by plugging that 4 in. And give me a second to do that. Okay, when you type all that in, you get 37. Now, maximum height, the height of a point is its y coordinate, so here's your answer. That's your max height, the k value. There are times when it'll ask for the x value or the h value, and the way it would be phrased would be, what value of x maximizes the height? But they would actually be looking for the h in that case. But if they just ask for the max or min height, you're going to find the k value. It's not good enough to just list the point, because then you've got too much information and you're basically telling me you don't know which of the two numbers, the 4 or the 37, is the height. All right, so that takes us through